Okay, hey guys, my name is Garrett Burnham, and today I will be demonstrating a physics experiment exploring the question, how does temperature change affect the electrical resistance of materials? And for this experiment, what we've gathered here is a 6-volt battery, a couple of alligator clips here. I got my voltmeter here. I've got that set to V with a couple of dash lines and a solid line above it, and it's at 20 right now. And just hooked up to the battery with these leads. I've got a pair of them here going in. I've got negative 5.48. And what I'm going to do is I'm going to put some resistors on in between at different temperatures, both at room temperature, and I'm going to cool some down in the freezer, and I'm going to heat some up with a hair dryer. And we're going to see what that does to the volt reading. Okay, so we're back, and right now we're just doing a test with a room temperature resistor, and same setup as before. There's a resistor there hooked up. I'm not really sure if I've got that right, but we'll see. And the voltmeter is reading negative 1.09, flipping between 09 and 08. And next we're going to try the cooled down version, and we'll see what that does. Okay, so now what I've done is I've taken the resistor out of the taken the resistor out of the freezer, and it is now cold. And you can see I've got it hooked up to the battery there just like I had it last time, and the voltage has now risen to negative 1.69 volts. Still same settings and everything. So what we've seen is that the voltage has risen with the colder resistor as compared to the room temperature resistor. Okay guys, well I have some very interesting news to report. I just used my hair dryer over here to warm up one of my resistor that I was using before from the cold experiment, and I got it pretty warm, at least as much as I can with these resistors. They don't really conduct heat as very well. Got it set up same way as before, got it hooked up, same settings and everything, and the voltage has risen yet again by about 0.1 from the cold one, which is kind of weird because I wasn't expecting that. I was actually expecting it to go down given the physics of it. So I'm not really sure what's going on here, if I've done something wrong or if physics is just broken. But we see there we've got a negative reading of 1.78, which has risen from the last reading of about, I believe it was negative 1.69. Okay, so let's talk about what we saw before in that experiment. What we saw was that when we heated up the resistor, it actually caused an increase in voltage or a drop in resistivity of the resistor. Now that is not what we were expecting. We were expecting to see a drop in voltage and an increase in resistivity. Now the reason for this change is actually based on the atomic level. What happens when we heat up the resistor is that the atoms begin to move more violently, and that begins to shake off more electrons into the outer shells, which causes them to become free electrons, which allows them to carry a current better. So basically what we have before it's heated is an atom with a couple of electrons flying around like this, and that isn't really a lot to carry a current as compared to, say, a conductor, which could have many electrons flying around, which can easily carry a current. But what happens as we start to heat this guy up is that this nucleus starts vibrating more violently, which starts to kick off some more electrons. And each one of these electrons gradually decreases the resistivity inside the resistor itself. So overall, what we get from an increase in temperature is an increase in voltage and a decrease in resistivity. Now this is opposed to what happens in a conductor, which has many electrons already. What happens in a conductor is that as the atom gets excited, these electrons start flying around at increasingly greater speeds, and as they do that, they start to crash into the nucleus, or start crashing into some of the more tightly bound electrons and start to cause them to kick off, and each one of these collisions takes up energy from the electron, which creates resistance. A way that I like to visualize what happens in a conductor as temperature rises as opposed to when a resistor has a change in temperature that is positive. is to think about it kind of like a car trying to cross traffic. So here we have a road, and we have a couple cars here, and then we have our vehicle here sitting at an intersection trying to cross through. Now we all know that the less cars that are traveling across this road there are, the easier it will be to get from this road over to this side. So what happens basically when we heat up a conductor is that we add more cars to the mix, which essentially makes it more difficult to pass through. So in summary, what we can say is that an increase in temperature in a resistor gives us lower resistivity and higher voltage. Now in a conductor we see a higher resistivity and a lower voltage. Now with a lower temperature, a temperature decrease, we expect to see the exact opposite. Resistor, increase in resistance, and decrease in voltage. Conductor, decrease in resistance, increase in voltage.